Good day, Brainiacs! Welcome to Gentle Brainiacs, your accessible video guide in math. In today's video, we will be discussing topics regarding functions, the types of functions, worded problems, and real-life applications of functions. Let's begin.
So, what are functions? A function is a relation between sets that associates to every element of a first set exactly on the element of the second set.
There are many different types of functions. These include polynomial functions, radical functions, rational functions, exponential functions, logarithmic functions, and trigonometric functions.
Let's start off with polynomial functions. This is a function of the form of f of x is equal to a sub n times x of n plus a sub n minus 1 times x raised to n minus 1 plus ellipsis plus a sub 2 times x raised to 2 plus a sub 1 times x plus a sub 0, where a sub n is not equal to 0 and the exponents are all whole numbers.
Examples of these are f of x is equal to 3x squared plus 2x plus 1 and f of x is equal to 2x plus 1.
Next up, we have radical functions. This is a function that contains a square root. Example of this is f of x is equal to square root of 4 minus x.
Third, rational functions is any function which can be written as the ratio of two polynomial functions, where the polynomial in the denominator is not equal to 0. An example of this is f of x
Is equal to
x squared plus 4x minus 1 divided by 3x squared minus 9x plus 2.
Exponential functions, on the other hand, have the form of f of x
is equal to
bx, where b is greater than 0 and b is not equal to 1. Just as in any exponential expressions, b is called the base and x is called the exponent.
Fifth, logarithmic functions are the inverses of exponential functions. The inverse of the exponential function y equals a raised to x is x equals a raised to y. An example of this is log base 10 of 100 equals 2.
Lastly, trigonometric functions. A typical calculator has three trigonometric functions if it has any: sine, cosine, and tangent.
The other three that you may see, cosecant, secant, and cotangent, are reciprocals of sine, cosine, and tangent respectively. So you're probably wondering, how do I apply this in my daily life? Well, here's the answer.
An example of an exponential function is the growth of bacteria. Some bacteria double every hour. If you start with one bacterium and it doubles every hour, you will have 2x bacteria after x hours. This can be written as f of x is equal to 2x. With the definition f of x is equal to bx and the restrictions that b is greater than 0 and that b is not equal to 1, the domain of an exponential function is the set of all real numbers. The range is the set of all positive real numbers. The following graph shows f of x is equal to 2x.
A soda or vending machine. The user puts in money, punches a specific button, and a specific item drops into the output slot. The function rule is the product price. The input is the money combined with the selected button. The output is the product, sometimes delivered along with the coins and change, if the user has entered more money than required by the function rule.
Ever played craps at a casino? Each roll of the pair of dice produces a number from 2 to 12, and the probabilities of these rolls are a discrete function expressed as fractions with denominator 36. The probability of rolling 2 is 1 over 36. The probability of rolling 3 is 2 over 36. The probability of rolling 7 is 6 over 36. If you want to maximize your winnings, intimate knowledge of this function is a must.
How about in the supermarket? You might want to know how much 3 pounds of flour, 2 dozen eggs, and 3 quarts of milk cost. Before you check the prices, construct a simple polynomial letting f denote the price of flour, e denote the price of a dozen eggs, and m the price of a quart of milk. It looks like this: 3f plus 2e plus 3m. If flour costs $4.49, eggs cost $3.59 a dozen, and milk costs $1.79 a quart, you will be charged 3 times 4.49 plus 2 times 3.59 plus 3 times 1.79 is equal to $26.02 at checkout plus tax.
Even a taxi driver can benefit from the use of polynomials. Suppose a driver wants to know how many miles he has to drive to earn $100. If the meter charges the customer a rate of $1.50 a mile and the driver gets half of that, This can be written in polynomial form as 1/2, open parenthesis, $1.50, close parenthesis, x. Allowing this polynomial to equal $100 and solving for x produces the answer 133.33 miles.
That's it for today. I hope you learned something new today. Once again, we're the Gentle Brainiacs.